The sun. A blazing ball of plasma that dominates our sky, the sun is a magnificent and awe-inspiring celestial body. It is the star of our solar system, a celestial engine that drives our world, providing the energy necessary for life to thrive. Without the sun, life as we know it would not exist. Its warmth and light are essential for the survival of all living organisms on Earth. Its energy fuels our planet, its gravity holds us in orbit, and its light illuminates our days, creating the cycle of day and night that governs our lives. The sun is a vast sphere of hot gas, primarily hydrogen and helium, constantly churning and boiling with intense energy. It is constantly undergoing nuclear fusion in its core, converting these elements into heavier ones and releasing tremendous amounts of energy in the process. This process is what makes the sun shine so brightly. This energy radiates outwards from the sun's surface, traveling through space as light and heat, reaching our planet and sustaining life. Understanding the sun is not just about unraveling the mysteries of the cosmos. It is also about comprehending the fundamental forces that shape our existence. It is about understanding our own place in the universe and the delicate balance that sustains life on our planet. The sun's influence extends far beyond just providing light and warmth. The sun is our lifeblood, and its story is intertwined with our own. Its presence is a constant reminder of the intricate and beautiful connections that bind us to the cosmos. The sun is a layered structure, each layer playing a crucial role in its overall function. These layers work together in a complex symphony, creating the energy that sustains life on Earth. At the very center lies the core, the heart of the sun's energy production. This core is incredibly dense and hot, reaching temperatures of around 15 million degrees Celsius. Here, under immense pressure and heat, nuclear fusion takes place. This process is the powerhouse of the sun, where hydrogen atoms are converted into helium. Hydrogen atoms are forced together, fusing to form helium and releasing energy. This energy is in the form of light and heat, which eventually makes its way to the surface and beyond. Surrounding the core is the radiative zone, a dense region where energy slowly makes its way outward. This zone is so dense that photons of light can take thousands of years to pass through it. Photons of light bounce from particle to particle, gradually transferring energy, but taking thousands of years to traverse this zone. This slow journey is crucial for the stability of the sun's energy output. Above the radiative zone lies the convective zone. This layer is less dense and more dynamic, with currents of hot plasma moving in a circular pattern. Here, hot plasma rises towards the surface, cools and then sinks back down, creating a churning effect that transports energy. This movement helps to bring the sun's energy to its outer layers more efficiently. Finally, we reach the sun's visible surface, the photosphere. This is the layer that we see from Earth, and it is where the light and heat that we receive are emitted. This is the layer from which light and heat are radiated into space. The photosphere is about 500 kilometers thick and has a temperature of around 5,500 degrees Celsius. Above the photosphere lie the chromosphere and corona, the sun's outer atmosphere. These layers are much hotter than the photosphere and are the source of the sun's solar wind. These layers are visible during solar eclipses or with specialized telescopes. The chromosphere appears as a reddish glow, while the corona is a faint halo of light, extending millions of kilometers into space. The sun's energy production is a marvel of the universe. Deep within its core, under unimaginable pressure and heat, a process called nuclear fusion takes place. Hydrogen atoms are constantly colliding, overcoming their natural repulsion and fusing together to form helium. This fusion process releases a tremendous amount of energy. Imagine the power of countless atomic bombs exploding every second. That is the scale of energy production within the sun's core. This energy, in the form of gamma rays, slowly makes its way outward through the sun's layers, eventually escaping into space as sunlight. This nuclear fusion is a self-sustaining process. The sun's immense gravity holds the core together, maintaining the pressure and temperature needed for fusion to continue. This delicate balance between gravity and energy production is what keeps the sun shining. The sun may seem like a constant, unchanging presence in our sky, but it is far from static. The sun's surface is a dynamic, ever-changing environment, marked by phenomena like sunspots, solar flares, and coronal mass ejections, or CMEs. Sunspots appear as dark blemishes on the sun's surface. These are cooler regions caused by intense magnetic activity. Solar flares are sudden bursts of energy and radiation, often associated with sunspots. They release tremendous amounts of energy in a short amount of time. Coronal mass ejections, or CMEs, are massive eruptions of plasma and magnetic fields from the sun's corona. These events can have significant impacts on Earth, disrupting satellites, causing auroras, and potentially impacting power grids. The sun's influence guiding the solar system. The sun's influence extends far beyond its visible surface. Its gravity holds the entire solar system together, keeping planets, asteroids, and comets in their orbits. The sun's gravitational pull is what keeps us from hurtling into space, but the sun's influence goes beyond gravity. The solar wind, a stream of charged particles constantly flowing from the sun, shapes the environment of the solar system. This wind interacts with planetary atmospheres and magnetic fields, creating phenomena like auroras. The sun's energy also plays a crucial role in shaping planetary climates. The amount of solar radiation a planet receives influences its surface temperature and atmospheric conditions. The sun is the ultimate energy source for our solar system. Section 6. Life from light, the sun's gift to Earth. Life on Earth is a testament to the sun's life-giving energy. Plants have evolved to harness the sun's light through photosynthesis, converting it into chemical energy and forming the base of the food chain. The oxygen we breathe is a byproduct of this process. Energy drives Earth's climate, creating the seasons, weather patterns, and ocean currents that sustain life. The sun's warmth evaporates water, driving the water cycle and replenishing our freshwater sources. The sun's energy is essential for life in all its forms. From the smallest microorganisms to the largest animals, all life on Earth ultimately depends on the sun's energy. It is the driving force behind the intricate webs and the biodiversity that thrives on our planet. Section 7. The sun and technology harnessing the power of light. Humanity has long recognized the sun's power and sought to harness its energy. From ancient sundials to modern solar panels, we have developed technologies to track time, generate electricity, and even power spacecraft using the sun's energy. Solar panels convert sunlight directly into electricity, providing a clean and renewable source of energy. Solar thermal technologies use the sun's heat for water heating, space heating, and even industrial processes. The sun's energy holds immense potential for a sustainable future. Beyond energy, the sun also plays a vital role in communication and navigation technologies. Satellites orbiting Earth rely on solar panels for power, and GPS systems depend on precise timing signals from atomic clocks synchronized with the sun. Section 8. The sun's fate. A glimpse into the future. The sun, like all stars, has a finite lifespan. It is currently in its main sequence, a stable period of hydrogen fusion that will last for billions of years. But eventually the sun's hydrogen fuel will begin to run out. As the sun ages, it will gradually expand and cool, transforming into a red giant star. Its outer layers will engulf the inner planets, including Earth. Eventually, the sun will shed its outer layers, leaving behind a dense core known as a white dwarf. This process, while billions of years in the future, highlights the impermanence of even the most massive objects in the universe. The sun that sustains us will one day reach the end of its life cycle, transforming the solar system as we know it. Section 9. Our star, our future. The importance of understanding the sun. The sun is more than just a celestial object in our sky. It is a massive, glowing sphere of hot plasma, a star that has been burning for over 4.6 billion years. It is the lifeblood of our planet, the engine that drives our world. Without the sun, there would be no light, no warmth, and no life as we know it. Understanding the sun is not just about satisfying our scientific curiosity, it is about understanding our own place in the universe and the future of our species. The sun's behavior affects everything from our climate to our technology. By studying the sun, we gain insights into the processes that govern stars, including nuclear fusion, which powers the sun and other stars in the universe. We also learn about the origins of planetary systems, how they form and evolve over time, and the role the sun plays in this cosmic dance. The sun's energy sustains the delicate balance that supports life on Earth, from the smallest microorganisms to the largest ecosystems. We learn about the sun's influence on our climate, our technology, and our future. Solar activity can impact satellite communications, power grids, and even the health of astronauts in space. As we face challenges like climate change and the search for renewable energy sources, understanding the sun becomes even more critical. Solar energy offers a clean, sustainable solution to our growing energy needs. The sun holds the key to a sustainable future, providing an abundant source of energy that can help reduce our reliance on fossil fuels and mitigate the effects of climate change. Its study will continue to shape our understanding of the universe and our place within it. By unlocking the secrets of the sun, we unlock the potential for a brighter, more sustainable future for all of humanity.